In 2010, 40 turtles were reintroduced to a wetlands park. By 2017, the population was half the initial population. Assuming the population is decaying exponentially, write a function p of t representing the population p of turtles over time t. Since we're told that the population is decaying exponentially, let's write an exponential function. Let's assume that p of t takes the form a times b to the t. And we will let t represent the years since 2010. This is a good choice to make because it makes the data easier to work with. We don't have to deal with those huge numbers. And also, that turns this first data point in 2010, 40 turtles were reintroduced. That turns it into, in a sense, a y-intercept. We have the data point now 0, 40. And then we're also told in 2017, the population was half the initial population. So that means that when t is 7, the population is half the initial population. Well, the initial population is 40. Half the initial population would then be 20. So we have two data points. Let's use these data points to find the values of a and b. Using the first data point, 0, 40, that means that a times b to the 0 must equal 40. Recall that any non-zero number to the 0 power is 1. So I have a times 1 is 40, which means then that a is 40. So I can revise my model a little bit. So now I know that p of t is 40 times b to the t. Using the second data point, when t is 7, the population must be 20. So then 40 times b to the 7th power must equal 20. We now need to solve for b. I'll first divide by 40. So then b to the 7th is 1/2. Now remember, the new population was half the initial population, and we ended up with a half there. It's not a coincidence. If that had stated 1/3, we would have ended up with a 1/3 here as that factor change. So then solving for b, if b to the 7th is 1/2, then using a radical, I could say then that b is the 7th root of 1/2. Recall as well that radicals can be written with rational exponents. So I could also say that b is 1/2 to the 1/7 power. I can't do that calculation in my head, so let me bring up a calculator. And let's see, my calculator on the computer does not have a general radical button, so I'll have to use the exponent idea. So let's do 1/2. Let's see, 1 divided by 2 is 0.5, right? Now let's raise that to the 1/7 power. So I'll raise that to the parentheses, 1 divide 7, close the parentheses to do that division in the exponent, and now hit enter for the actual exponentiation, and I get 0.9057. So b is approximately 0.9, what was it? I forgot already. Was it 9057? 9057. So then my conclusion is that the function p of t is 40 times 0.9057 to the t.